All right, continuing in the vein of the projectile motion problems, we have here a type 2 problem. So these type 2s are ones that involve an object when it gets to the highest point of its motion, when it gets up to its peak. So remember, at the peak, we're going to have a final velocity of 0, but that is only in the y direction. When we get to that highest point, the object stops vertically. Our velocity horizontally is always constant. Whatever it starts at is what it ends at as well. But for these types of problems where we have the highest point, we come to a stop vertically, not horizontally. And one of the unique things, and we'll see this again in the type 3, is for these problems we have this situation where we have a speed at an angle. And in order to deal with that, that's giving us our initial speed both in the x direction and in the y direction. But neither of those initial velocities are 15. We can't use that 15 anywhere in our chart. Instead, what we have to do is take that velocity of 15 meters per second with that angle of 60 degrees and break it into its components, just like we did in the first half of this unit. So on the bottom here for the x direction, that will be 15 times the cosine of 60, and here on the y-axis, 15 times the sine of 60. So I'm going to go ahead and calculate both of those. 15 times the cosine of 60. I'm going to hope that it's in degree mode. Switch it there. And that is 7.5. So here we've got 7.5 meters per second. And back again, 15 times the cosine of 60. Oh, I'm sorry, that was that. I'll have to go back and switch it. Sine of 60. So the y is actually 13 and the x is the 7.5. So let me go ahead and move that over. 7.5 there and 13 meters per second in that x direction. So by doing that, by breaking that vector into its components, we get this x velocity here and the y velocity there. And those are both initial velocities. So when we go to build up our chart, we already know a lot of information. We got x, y. Come on. Delta, v naught, v final, a, and t. Just like always, 0 and 10 for our x and y, but here I'm going to make that 10 negative. I've got upwards velocities like this one here, the initial 13 meters per second. My delta y is going to be upwards, so I've got this upwards and downwards. I want to make sure that I assign a specific direction. I like to make downwards negative, so that is why I've got that negative 10. And like we said before, our final velocity in the y, because we're at the highest point, is going to be 0. I also take those initial speeds into account. So we have in the x direction 13 meters per second, and in the, that's in the y direction. Slide that over there. And in the x direction, we've got 7.5. We got those from breaking those up. So if I'm looking for the ball's maximum height, I'm looking for delta y. So if I'm dealing with delta y, v naught, vf, and a, the equation I want to go ahead and use, vf squared equals v naught squared plus 2a delta y. Start plugging some stuff in. 0 equals 13 squared plus 2 times negative 10 times delta y. Scroll down here a little bit. All right, so 13 squared, let's do 13 times 13. It's going to be 169 plus negative 20. I combine those two values. Big thing here, do not add that negative 20 to 169. Instead, we're going to subtract 169 from both sides. And then divide by negative 20. So if we do that, divide by 20, 8.45 meters. There you have it. So 8.45 meters is how high up this object got. Question might arise, well, why did we even need that initial velocity? We didn't do anything in the x direction. Some questions could be set up so that you have to use the x direction as well. I could ask you, how far away horizontally did our object get when it got to the highest point? In that case, you would have to find the time. Oh, that was different. You'd have to find the time right here using the using the y direction again, and do that same process over again that we did from the previous video where we found the time and then use that to find the delta x. More often than not, the question though does just ask for the maximum height. I don't know why, oh my gosh, this whole thing's freaking out. Again, most of the time it does just ask for that maximum height. You just have to set up that triangle, and in the process you end up getting a little bit of extra x information. In the next video we'll talk a little bit about the type 3 problems and how we can easily go from a type 3 problem back to one of these type 2 problems as well.